Hello, today we're gonna go through the solution for homework 4. The first problem is 3.70. So it has a rectangular gate here, and we have a pivot which is denoted as point B, and the problem is asking whether this gate is stable or unstable. So we have a pivot point B, and we have a point A that's a fixed point stopping this gate rotating this way. Okay, but we don't have anything at here, so we can actually rotate clockwise. So now the problem is simplified to where is the resultant force acting here. So for example, if the resulting force is acting somewhere here, so it's very obvious this gate will rotate clockwise, so it's unstable. But if your resultant force acting here somewhere, then the force is kind of moving, getting the gate rotating counterclockwise, which this point A will stop it. So this situation means it's stable. So now we kind of get an idea how to solve this kind of problem. The first thing we need to do is to find the centroid of the plate. So before that, we need to know the length of the gate first. So we have depth equals to 8 meters, and we have an angle theta which is 45 degrees. So now we need to find the length of the gate, which will be h. It's gonna be the depth over the sine 45 degrees, which is 8 meter times square root of 2, which is 11.31 meter. Okay. So now we have the length of the gate. The next step is to find the centroid, which is y bar is gonna be h divided by 2. This will give us 5.65 meter. Okay. So the next step is to compare the centroid and the YCP. So YCP equals to I over y bar times A plus y bar here. Okay, so we know the y bar, but we don't know the I and A. So the next step is to find your A. So A gonna be the width of the gate times the length of the gate, and we'll keep the B here. So we have H here, so it's gonna be 11.31 B. Okay, and I, which gonna be 1/12 times B times h to the power of 3, which is gonna give us 11.31 to the power of 3 times over 12 times B. So this will give us 120.561 B. Okay. Now we can substitute this to YCP. So it's going to be 120.561 B over 11.31 B times 5.65 plus 5.65. So the B's will cancel out and we can find our YCP gonna be 7.54 meter. So we have find the YCP. The next step is compare the location of YCP to the pivot point. Let's say the pivot point is YP, which is gonna be 11.31 meter minus the 3.5 meter, which gonna be 7.81 meter. So we can see YP is larger than YCP. That means your resultant force actually is higher than the pivot point. Therefore, the skate is unstable. So let's go back and look the figure here. So the entire length is 11.31. We have 3.5 meter from the bottom to point B. So we have 7.81 meter from the top to the point B. And we have the force somewhere here. .54. Okay. Now let's look at the second problem, 3.91. So we have a hydrometer in a sink, and the length of the steam in the sink is 7.5 centimeters, and the bulb, which is the round part of the hydrometer, displays 1 cubic centimeter. So it also gives us the steam area A, which is 0.1 to the square centimeter, and we are asking to find the weight of the hydrometer. So for this kind of problem, you have the weight, which is equals to your buoyant force. So for this problem, we have water at 15 degrees Celsius. So our gamma water will be 9,800 Newton per cubic meter. Okay. So now we need to calculate the buoyant force FB, which is gonna equals to the volume times gamma water. In our problem, this volume is the volume of the stick plus the volume of the bulb. So for the steam, we have the area times the Z, which gives us the volume of the steam, and for the bulb, we already have it, which is 1.0 cubic centimeter times gamma water. Okay. So the area is 0.1 square centimeter times 4.7 centimeter plus 1.0 centimeter. And we need to convert centimeter to meters. So 1 cubic meters is 10 to 6 power cubic centimeters skim water, which gives us 1.47 times 10 to the negative 6 times gamma water is 0.0 Newton per cubic meter. So our FB is 0.0144 Newton. Therefore, the weight of the hydrometer is also 0.0144 Newton. For problem 4.14, we have water flows in the passage as shown here. The flow rate is decreasing with time. So we're asking whether the flow is steady or unsteady, uniform or non-uniform. So for steady and unsteady, we need to check if the property of water is changing with time or not. So because the flow rate is decreasing with time, so it's unsteady. And because we have a narrower in the left and a wider channel on the right, so the velocity here, V2, should be smaller than V1. So for point 1 here and point 2 here, we actually have a velocity change. So the uniform and ununiform is about a property change with location. So when we compare the P1 and the P2 here, we can say it's non-uniform. So let's look at 4.117. So this problem asks us to classify each of the following as one-dimensional, two-dimensional, or three-dimensional flows. So for the first problem, it says it's a water flow over the width of a long spillway of the dam. So it'll be something like this. Okay. So this will be 2D. And the problem B is flow in a straight, constant diameter pipe. So be something like this. So it's 1D. For C, flow in a constant diameter pipeline that follows the contour of the ground in hilly country. So it's kind of confusing because it has more, much more describing about the pipe going where, but the thing is it's still a constant diameter. So you can still simplify it to could not draw it pretty good, but because it's still a constant diameter here, so this problem still is 1D. For problem D, it says we have airflow from a slit in a plate at the end of a large rectangular duct. So it will be something from a slit, and we have airflow going out. So it will be 2D. Okay. So for problem E, it's airflow past an automobile. So it will be something if you have a car, you have airflow that's changing in the directions, both in the XYZ. So it has different velocity in all directions, so it will be 3D. And for F, it's similar thing. You have a house here, you have airflow. So those two are the very similar thing. It's also 3D. Okay, for the last one, you have a water flow past a pipe that's laid normal to the flow across the bottom of a wide rectangular channel. So it will be something, you have a channel here, you have a pipe, and then you have water flowing. So actually it will goes surround the water flow like that. So actually it's changing in this direction but not across the channel, so it's 2D.